Hey guys, this is a spiral review for Spiral 7. We're going to start off by looking at some systems of equations and inequality stuff. First off, I've got a system of inequalities. I'm going to probably try to at least set the first two to be numbers that are a little bit easier to work with. What the heck, I'll just do these all in standard form because they come out pretty nice actually. If I plug in 0 for x, I get 9 for y. And if I plug in 0 for y, I get 3 for x in the first one. All right, so 0, 9, and 3, 0. And given that this is a not equals 2, this is going to be a dashed line that goes through these points. Ooh, that's a nice, very evenly keeled slope there. Okay, last piece of this, I'm going to check the point 0, 0. And I get 0 plus 0 is less than 9. That's true. That means that we're going to shade in on this side of my graph. Okay, second one. X plus y is greater than or equal to 7. If I make my table for standard form, 0, 0, 7, 7, 0, 7, and 7, 0. If I plug in the point 0, 0, we get 0 is greater than or equal to 7, and that's false. That means I'm not going to color in this side. I need to shade in the opposite side of my red line. Okay, and finally, we've got 2y plus 3x is less than or equal to 12. If I plug in 0 for y, I get 4 for x. And if I plug in 0 for x, I get 6 for y. Okay, and for this, we're going to plug in the point 0, 0. I switched my marker a little bit too fast. And if I plug in 0, 0, I get 0 is less than or equal to 12, which is true. Okay, that means that we're going to color in this side. And I don't know about you guys, but it appears to me that there's a very small region up here that appears like all three colors are there. And unfortunately with my stylus, I am terrible at making accurate lines. So that might be a little bit off, but that seems to be the best place. Problem number 2. We're looking at a system of equations to represent the situation of candy. And we're looking at buying bags of candy for Halloween. He's going to buy lollipops that cost $3.50 a bag. Call that L. Going to buy chocolates, which cost $4 a bag. Cool. So it looks like I don't know how many bags. So I might say that L plus C is equal to 30, because that's how many total bags he's going to buy. I also know that 350 times L plus 450 times C is equal to his entire budget of $114.50. Okay, I'm going to solve this using elimination, and to do that, I'm going to multiply my entire top equation by 3.5. In fact, I'll multiply by negative 3.5, so I don't have to deal with subtraction. All right, we get negative 3.5 L minus 3.5 C. I'll add zeros to make that easier to see. And then we're going to have negative 90 minus another 15 is going to be negative 105. 0, 0. We end up with 0. 1C, hey, that's convenient. And 114 minus 105 is going to be something like 950. And if you're following along, you might have noticed I made a mistake in writing my equation, because it's not $4.50 a bag, it's $4 a bag. So $4 minus 350 would be 0.5C. Okay. Divide both sides by half, and I get C is equal to 19. That means he'd be buying 19 bags of chocolate. If we're buying 30 bags overall, it means he's buying 11 bags of lollipops. Our next problem is to write an equation for the graph of this curve. Hint, it's a parabola. So I'm going to begin with something like this. Okay, I know this is going to be y equals ax minus h squared plus k. Vertex appears to be at negative 2 comma 8. It'd be nice if I told you that that was definitely the vertex, but I'm okay with that. So y is equal to x plus 2 squared plus 8. And then I'm going to use my other 0.53 to find a. So y is going to become 3 is equal to a. 5 plus 2 squared plus 8. Negative 5 is equal to a times 49. A is equal to negative 5 49ths. My final equation, y is equal to negative 5 49ths. Multiplied by x plus 2 squared plus 8. And we're done. For number 4, we have to sketch a graph of this equation. We're going to include at least 3 labeled points. Cool. So I'm going to choose some points that are kind of interesting. The first one I'm going to choose is going to be 3, 6. That's my vertex. Now from this, I'm going to make a decision. Because I've chosen the point 3, 6, I know that's my vertex. However, I have a negative a third in front, and that makes for an awkward problem, because if I multiply negative a third times whatever this is, I'm going to put the fraction. What I'm going to choose are some x values to make this a little bit easier to work with. In other words, multiples of 3. So in looking at this, the first multiple of 3 that I can get is going to be 3 more than what we have now. So in other words, 6 minus 3 is 3. 3 squared is going to be 9. Negative a third times 9 would be negative 3. Plus 6 would be 3. So we could do this at 6 comma 3. Okay. I'm going to go 3 below, and that should be at 0. Let's see if that works too. 0 minus 3 is negative 3 squared is 9, and we end up at the same place. Choosing these points makes it a little bit easier for me to deal with some of these weird values. So we've got 0, 3, and we've got 6, 3. Now I'd like to see a nice smooth curve going through those points much better than I was able to do. Next up, we've got some factoring. All right, so I'm going to start factoring. I'm going to multiply my first and last terms, my a and c. I'm going to try to find things that multiply to 6x squared and also add up to 5x. Those two things are going to be, well, not 1 and 6, because that adds up to 7. 2 and 3, I have a winner. 2x squared plus 2x plus 3x plus 3. That's my 5x in the middle there. Factor the first half. 2x in common, I've got x plus 1 left over. Second half, they've got a 3 in common, and I've got x plus 1 left over. I'm going to factor again. This time I've got x plus 1 in common. So x plus 1 gets factored out, leaving me with 2x plus 3. If you're just asked to factor, your problem is now complete. Next problem, we've got 35x squared plus 32x minus 3. First thing, again, I'm going to multiply my a and c term. It's going to be negative 105x squared. I'm trying to find things that multiply to negative 105 and add up to 32. I have a big hint because 35 and negative 3 is positive 32, and actually that's exactly what I want. So that's kind of convenient. I can just plug those numbers in. I just looked at the two numbers that I multiplied, and they happened to be the ones that also add up to the middle piece. So we've got 35x squared plus 35x minus 3x minus 3. 35x, x plus 1 minus 3, x plus 1. And now we've got another situation where I've got x plus 1 and x plus 1. I can factor that out. And my leftovers are 35x minus 3. And again, if you're just factoring, at this point you are done. Now we've got to do some solving by factoring. I'm going to start exactly the same way. But this time I'm going to keep the equation equal to 0 at each step. Okay, so we're looking for things that multiply to negative 45x squared and add up to negative 12x. So that's times and that's plus. All right. Things that multiply to negative 45x squared, negative 1, positive 45. Nope. Negative 2, no, negative 3, positive 15. We have a winner. So we got 5x squared minus 3x plus 15x minus 9 is equal to 0. X, 5x minus 3 plus 3, 5x minus 3 is equal to 0. 5x minus 3 is in common. I've got x plus 3 as my leftovers. That means that 5x minus 3 is equal to 0. In other words, x is 3/5. And x plus 3 is equal to 0. That means that x is negative 3. Another solving by factoring problem. This one we got to do a little bit of work first. I'm going to add 5x to both sides to get everything on the same side. So we get 2x squared plus 5x plus 2 is equal to 0. I like writing that in standard form because that helps me to deal with the factoring. So 2 times 2 is 4x squared. Try to multiply to 4 and add up to 5x. Okay. That's going to end up being 4x and 1x. So 2x squared plus 4x plus 1x plus 2 is equal to 0. Factor the first half, 2x and x plus 2. Factor the second half. I can take a 1 out. This is a sneaky trick. And I get x plus 2. I notice that I've got x plus 2 and x plus 2. I can factor it out. X plus 2, and then my leftovers are 2x plus 1. Still equal to 0. Anytime two things multiply to 0, one of them must be 0. So x plus 2 is equal to 0. In other words, x equals negative 2. Or 2x plus 1 equals to 0. In other words, x equals negative a half. Next up, we've got some completing the square. This is going to have some steps here to help you kind of remember what to do. These will not be provided on the spiral itself. First up, on the left side, I've got to get the constant away from the variable. Okay. And 1 in front of x squared. So there's 1 in front of x squared already. Let's add 10 to both sides, and we've got x squared plus 8x is equal to 10. Cool. That's my cleanup step. Next, I got to find the c value. Split up my b term. Okay. X squared plus 4x plus 4x is equal to 10. Done. Multiply the two pieces together to find c. c equals 4 times 4 equals 16. Nice. Add the c value to both sides of the equation. X squared plus 4x plus 4x plus 16 is equal to 10 plus 16. That means 26 on the side, and on the left side, I'm going to factor. This is going to factor into x plus 4 and x plus 4, in other words, x plus 4 squared. Okay. If you need help with factoring, go back a little bit in the videos and look at the previous section. And then finally, we're going to solve by the square root. Square root both sides. X plus 4 is equal to plus or minus the square root of 26. X is equal to negative 4 plus or minus the square root of 26. All right, we're looking at another completing the square problem. Again, we've got the hints that will not be on your spiral. But looking here, I see that everything here is divisible by 5. A good idea is always to get rid of any common factors before you even begin. It tends to make your life much happier. So we got x squared plus 6x minus 5 is equal to 0. Okay, that also happens to get the constant away from the x squared. So now if I add 5 to both sides, I get x squared plus 6x is equal to 5. Okay, I'm going to split up my middle term. X squared plus 3x plus 3x is equal to 5. I'm going to multiply those two pieces together to add 9 to both sides. Factor x plus 3 quantity squared. That's from the 3 that's there. And that's equal to 14. Getting the x squared part gone, we got x plus 3 is equal to plus or minus the square root of 14. X is equal to negative 3 plus or minus the square root of positive 14. Now we got to solve by some square roots. We're also going to have some potentially complex numbers here. In other words, those I things. 4x squared plus 25. I could factor this. However, if I don't have an x term, I can just treat this like I would any other problem. Plus 25 plus 25. 4x squared is equal to 25. Divide 4. X squared is equal to 25 over 4. Square root both sides. X is equal to plus or minus the square root of 25 over 4. In other words, the square root of 25 over the square root of 4, or 5 and 2. Second one, it's going to have a similar setup. To get that x squared by itself, because I don't have an x term, I can solve by square roots. Add 49 to both sides, so I've got 16x squared is equal to 49. Divide by 16, I get x squared is equal to 49 over 16. Do some square rooting. X is equal to plus or minus, and square root of 49 is 7. Square root of 16 is 4. Second to last problem here. We're going to start it the same way. Dividing both sides by 3, I get x squared is equal to negative 4. Square root both sides, and here's where I begin to run into some trouble. So if I've got x squared is equal to 4, if I square root both sides, I get x is equal to plus or minus the square root of negative 4, which doesn't compute. I could rewrite that as x is equal to plus or minus the square root of 4 multiplied by the square root of negative 1. In other words, x is equal to plus or minus 2, that's the square root of 4. Square root of negative 1 is I, and I'm done. Last one, we're looking at 16x squared plus 81 is equal to 0. Let's minus 81 to both sides. 16x squared is equal to negative 81. Divide by 16. X squared is equal to negative 81 over 16. I'm going to square root both sides, and again we end up with the same conundrum. X is equal to plus or minus. This is going to be a negative square root, so I'm going to rewrite that as the square root of 81 over the square root of 16 multiplied by the square root of negative 1. So I'm factoring the negative 1 out so I can deal with the rest of this. And from that I get x is equal to 9 over 4 multiplied by I.